This is a truly tantalizing image. Why is it tantalizing? This is Proxima Centauri. Since its discovery over 100 years ago, it has captivated astronomers worldwide. It lies so despairingly close, yet it would take generations to reach. Though invisible to the naked eye, it remains the closest star to our solar system. At one point, it was the lowest luminosity star known to man, yet also the most active one. As if the paradoxes of this star weren't alluring enough, scientists recently discovered a seemingly Earth-like exoplanet in its orbit, sparking discussions about interstellar colonization that involve Mark Zuckerberg, Elon Musk, and Stephen Hawking. It's almost as if it is knowingly toying with our unquenchable curiosity for what lies beyond. If you're anything like me, you can't wait to uncover everything about this enigmatic star. I'm Alex McColgan, and you're watching Astrum. Join me today for a whistle-stop tour of the Alpha Centauri star system, from the binary stars Alpha Centauri AB to a deep dive into Proxima Centauri, its recently discovered planets, a controversial possible discovery, and potential flyby missions in the future. Leaving Earth, it would take just over 4 light-years to reach the closest known stars to our solar system. I say stars, because they are technically a triple-star system. Collectively known as Alpha Centauri, they consist of Rigil Kentaurus, Alpha Centauri A, Ptolemy, Alpha Centauri B, and Proxima Centauri. Rigil Kentaurus and Ptolemy form the binary star system Alpha Centauri AB, located 4.37 light-years from Earth, orbiting a common center every 79.76 years. If you're south of the 40th parallel, you'd see them at night as a single star, the third brightest in the sky, following Sirius and Canopus. The binary Alpha Centauri system was discovered in 1689, but it took over 200 years for the third star to be revealed. Luck came in 1915 for Scottish astronomer Robert Innes, then director of the Union Observatory in Johannesburg, South Africa. While comparing photographic plates with a blink comparator, Innes noticed a faint star that had shifted over 5 years, with movement matching the Alpha Centauri binary he was observing. Further investigation confirmed that it was even closer to the Sun than the Alpha Centauri pair, a finding soon verified by other astronomers. Paradoxically, it was the closest yet dimmest known star at that time. The surprises didn't stop there. In 1951, American astronomer Harlow Shapley discovered that Proxima Centauri is a flare star and the most active one known then. Over the last 70 years, Proxima Centauri has become a hotly studied star, no pun intended. With the recent discovery of an Earth-like exoplanet orbiting it, interest will only grow. But let's get to know this star a little better before placing grand expectations on it. Located 4.24 light-years from us, Proxima Centauri is slightly closer than Alpha Centauri AB. It is a main-sequence red dwarf star with a mass of about 12.2% and a diameter 15% that of our Sun. Despite its smaller size, it is about 40 times denser than our Sun. Its low mass makes the star's interior totally convective, creating a magnetic field that occasionally releases energy in the form of flares. Proxima Centauri thus experiences random, drastic changes in brightness and energy. On May 6, 2019, it exhibited the brightest flare event recorded, emitting radiation across the electromagnetic spectrum, including X-rays. For perspective, Proxima Centauri's baseline X-ray luminosity rivals that of our Sun, a far larger and hotter star, and can increase by up to 2 orders of magnitude during flares. Not only does it have more intense solar activity than our Sun, but it also experiences a higher frequency of it, with an estimated 88% of the star's surface active at any given time. This level surpasses even the peak of our Sun's solar cycle. Yet, while it may seem like a fiery ball of fury, remember, comparing it to our Sun is like comparing apples and oranges. Unlike our Sun, Proxima Centauri is a red dwarf and is considered to have low activity compared to other red dwarfs. Unlike the Sun, which scientists estimate will burn only 10% of its hydrogen before burning out, Proxima Centauri is expected to exhaust almost all its fuel before leaving the main sequence, about 4 trillion years from now, long after Earth, the Sun, and our solar system are gone. Proxima Centauri is situated 0.13 light-years, or 2 trillion kilometers, from Alpha Centauri AB. You might wonder why it's considered part of the same stellar system despite the vast distance. Evidence shows it's gravitationally bound to the Alpha Centauri AB binary with an orbital period of about 550,000 years. How it ended up in this orbit is still speculative. Two main scenarios exist, one where Proxima Centauri formed with Alpha Centauri AB, possibly sharing elemental composition, and another where it was captured by the binary's gravity, leading to a highly eccentric orbit stabilized by the galactic tide and stellar encounters. Regardless of how Proxima Centauri became part of this system, calculations suggest that in 3.5 billion years, it will drift away as Alpha Centauri AB loses mass. The binary star system itself is predicted to eventually split and evolve into two white dwarfs in about 12 billion years. As our closest neighbors, we know much about Alpha Centauri AB, but we'll explore this binary star system in more detail in another video. For now, all eyes are on Proxima Centauri. The search for exoplanets around Proxima Centauri has been ongoing since the mid-2000s without much luck. But researchers didn't give up. Not only was it our closest neighbor, but also a red dwarf, with an estimated 20 to 40% chance of a planet orbiting within its habitable zone. That patience was rewarded with the discovery of Proxima Centauri b. Observations at the European Southern Observatory in Chile identified anomalies in Proxima Centauri that couldn't be explained by flares or other solar activity. The data suggested that a planet might be orbiting it. In January 2016, the Pale Red Dot campaign, a coordinated effort from multidisciplinary scientists and ground-based telescopes around the world, was launched to confirm if this suspected planet could be identified. In August of the same year, the discovery of exoplanet Proxima Centauri b was announced. It is at least 1.07 times larger than Earth and sits 20 times closer to Proxima Centauri than we are to our Sun. This exoplanet completes its orbit in just 11.2 Earth days. Even though Proxima b is within Proxima Centauri's habitable zone, that doesn't guarantee it could sustain life. Habitability depends on more than just the presence of liquid water. For instance, the intense solar activity would bombard the planet with 10 to 60 times the amount of UV and X-ray radiation Earth receives, so would need SPF 3000 sunscreen to make the journey worth it. Another factor to consider is whether an atmosphere could survive such conditions. Atmospheres are crucial for maintaining water-friendly surface pressure, shielding from harmful space weather, and regulating planetary climates. The radiation Proxima b is exposed to might strip away key atmospheric components over time. Frustratingly, beyond its distance from its star and orbital period, we know little about Proxima b. It's unlikely to have moons due to the instability of their orbits over time, and it's thought that the planet is tidally locked to its star, which doesn't favor habitability. It also likely formed under very different conditions from Earth. If it formed at its current distance, it would have evolved faster, experiencing stronger impacts and less water. However, some scientists speculate the protoplanetary disk's material wouldn't have supported its formation so close to the star. More likely, the planet formed farther out and drifted to its present orbit around Proxima Centauri. Speculations on its surface range from a frozen planet to one with oceanic expanses like Earth, though a world of oceans is less likely if it's tidally locked, to a dry, water-free world or a subsurface ocean like Europa's. In short, we don't really know. We haven't directly imaged the planet yet, so we'll need a future flyby to get a better idea, which some moguls are already planning. If it happens, it may be as groundbreaking as the Voyager flybys in the 70s and 80s, but more on that later. 6 years after Proxima b's discovery, Proxima d made global headlines. The first signs of this planet appeared in 2020, when a weak 5.15-day signal was detected in the radial velocity data during a study on Proxima b's mass. After more data collection and analysis, scientists confirmed the discovery of Proxima d in February 2022. So far, we know it's a sub-Earth planet, with at least 25% of Earth's mass, orbiting the star every 5.1 days. At 4.3 million kilometers away, it's too close to have a habitable equilibrium temperature, which would rise to 87 degrees Celsius. It's likely tidally locked, bombarded with so much radiation that finding life is improbable. However, this planet is promising in another sense. It's the lightest planet detected using the radial velocity method. Since telescopes can't directly see it, scientists rely on the characteristic wobble in the star's movement to indicate a potential planet. The more massive the planet, the more evident the wobble. For Proxima d, the wobble was nearly imperceptible. That we caught it and confirmed it as a planet demonstrates a remarkable technological milestone. But astronomy isn't always so clear-cut. With breakthroughs and celebrations on one end come bleak uncertainties on the other, exactly where the controversial exoplanet Proxima c stands. Initially detected in 2019 via the same radial velocity method that found Proxima d, Proxima c's existence was then confirmed in 2020 with Hubble astrometry data. However, in 2022, another team challenged the initial radial velocity data, suggesting the anomalies might be due to minor, unaccounted systematic errors during data extraction, essentially a miscalibration. The issue arises because, unlike Proxima d, which orbits close to its star, Proxima c's data places it far from the star, with an estimated 1,928-day orbit. There is no similar example of a wobble detection for such a low-amplitude planet at such a long period, says Paul Robertson, an astronomer at UC Irvine. While this doesn't necessarily mean it's wrong, it will need confirmation from more observations. If Proxima c exists, skeptics may need more convincing data. If it doesn't, it's unclear why Hubble data seem to confirm a planetary signature. We'll just have to wait for future studies. With Proxima b's discovery and Proxima Centauri's relative proximity to us, it's an ideal candidate for a future flyby. Reaching this neighboring star system with current propulsion technologies would take thousands of years. Emerging techniques like solar sails or nuclear propulsion might make such a journey possible within a human lifetime. These possibilities inspired Project Breakthrough Starshot, an initiative led by investor and physicist Yuri Milner, the late Stephen Hawking, and Mark Zuckerberg, aiming to reach the Alpha Centauri system within the first half of the 21st century. The plan is to conduct a flyby mission by sending microprobes weighing a few grams at 15 to 20% the speed of light, potentially launching as soon as 2036. At this speed, the probes would reach Alpha Centauri in 20 years, and Earth would receive the first data for years after that. Following the initial flyby, the probes could visit the exoplanets, collecting data on their atmospheres, much like the Voyager missions did for our solar system's outer planets decades ago. The team hopes to rely on the yet-to-be-developed star chip, a gram-scale wafer equipped with cameras, photon thrusters, a power supply, navigation, and communication equipment, essentially a fully functional space probe. Based on Moore's law, which states that the speed and capability of computers can be expected to double every 2 years, the plan is bold and ambitious, yet not without its challenges. The team proposes to power these microprobes with 100 gigawatts of Earth-based lasers, equivalent to the output of 100 large nuclear power plants, all concentrated on probes just centimeters wide. Plus, every component of these tiny probes must be designed to withstand extreme acceleration, cold, vacuum, and collisions with space dust. With this in mind, perhaps the project would more aptly be named Project Breakthrough Longshot. However, if space exploration history has taught us anything, it's that missions facing immense hardship and slim odds can still become monumental achievements for humanity. Proxima Centauri might be the next entry in the history books, and let's hope we're around to see it. Have you ever wondered why only some materials are magnetic? Magnetism operates on the scale of atoms and electrons, with each electron creating its own magnetic field when it moves. If these fields aren't aligned, they counteract each other, resulting in no net magnetism. This is a principle that Novium, the sponsor of today's video, understands well. They've used award-winning creative design to craft a unique hover pen that floats in the air through a delicate balance of magnetic fields working together. Novium pens are high-end, comfortable, and come in 4 different colors to match your style. The premium edition even includes an option with an actual meteorite shard, from a meteor 20 million years older than Earth itself, making it a fantastic Father's Day gift or a great gift in general. If you want a pen that sparks your own creativity, scan the QR code or click the link in the description below to get 10% off all hover pens, along with free shipping to most countries. Check it out, who wouldn't want a piece of space in their hand? Thanks for watching. And thanks to our crew of astronauts on Patreon, who help us make science knowledge freely available to everyone. Chasing the algorithm can be hit or miss sometimes, so your support helps us keep creating the content we love. If you haven't joined our Patreon yet, now is the perfect time to join the party. Just sign up with the link in the description. When you join, you can watch the whole video ad-free, see your name in the credits, and submit questions to our team. Once again, a huge thank you from myself and the entire Astrum team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.